Alrighty, hey Year 11 Methods, welcome back to another fun-filled week of school. This week we are continuing with our gallery of graphs from chapter number 4. This one we're looking at is the graph of y equals the square root of x. Now what you do need to remember is obviously here the square root of x is, even though there's not a 2 there, that's really a 2, and that's x to the power of 1. So the square root of x is the same as x to the power of 1 over 2, or x to the power of 1/2. Yep. So that's just a friendly reminder about that. Again, if you consider the equation y equals the square root of x, if you were to take the square of this side, that would get rid of the square root. You'd just be left with x on this side. And if you take the square of this side, obviously you'd be left with y squared. Yep. So this graph here is the same as x equals y squared. Yep. If we're talking about the square root of x, y equals the square root of x, it's just looking really at the top half of this graph. Yep. To get the bottom bit here, I'll delete that. It's going to be the negative of the square root of x. Yep. So it's flipped in the or mirrored in the x-axis to give you that there. Yep. Now, it gives some pretty obvious things here. Again, if you have the coordinates, if you have x as being 0, obviously the square root of 0 is 0. Square root of 1 is 1. Here, if you've got x is 4, the square root of 4 is 2. Square root of 9 is 3, and so forth. Yep. So you can get those points from the graph y equals the square root of x. Notice here they've labelled some on there. Now again, this type of formatting should be no surprises here. Yep. This is the basic form of the graph y equals the square root of x. Obviously this h value will determine how far it's translated left and right. This k value will determine how far it's translated up and down, and a is obviously affects the dilation of the graph. So here again it says sketch the graph. We've got 3 square root of x plus 1 take away 6. The way I remember, the starting point of the graph is going to be defined by where it's translated to. Yep. So again, underneath this square root sign here, I think, okay, well, what does x need to be so that that part underneath there, underneath there is equal to 0? Okay, x would have to be -1. Yep. So obviously it's translated to the left by 1. Also, here we've got -6 on the end, which means it's translated down 6 units. Yep. So if it goes left by 1 unit and down by 6 units, you end up at the point starting. Normally it's at 0, 0 as a default, but if it moves to the left by 1 and down by 6, you end up at -1, -6. Yep. Cool. The other things that you need to know is obviously what the y-intercept is. To find out where it cuts the y-axis, we know by now you need to make x equal to 0. So you can plug x equals 0 into the equation here. You're going to have 0 plus 1 under there. 3 times the square root of 1 take away 6, and you'll end up at -3. Yep. Likewise, when you want to find the x-intercept, you need to make y equal to 0. So writing out the equation, making y equal to 0, rearranging things, moving the 6 over here by adding 6, dividing both sides by 3. You've got the square root of x plus 1 equals 2. Take the square of this side, take the square of this side, etc., etc., and we get x equals 3. Yep. So you can get those things happening from there. Cool. This one here, it says sketch the graph of y equals -2 square root of x take away 1 plus 3. Again, thinking about where this graph's starting, x take away 1, this part of the graph, to make it equal to 0, x would have to be 1, so positive 1, so it moves to the right by 1, and here plus 3 means it moves up by 3. Okay, up by 3. So if you're at 0, 0 and you move right by 1 and up by 3, you end up at 1, 1. So that's where the graph's going to start. You know it's a negative version as well. Yep, there's a negative in front. So instead of going up like that, it's mirrored in the x-axis. It's going to go down like that. Cool. From there again, you need to think logically. If the graph is going from here this way, it's not going to cut the y-axis. So there's no point trying to find a y-intercept. So no need to make x equal to 0 and find that. It doesn't exist, yep. But it is going to cross the x-axis. So that happens when y is equal to 0. So make y equal to 0, write out the equation, rearrange things, and you can get the solution there for that. It happens at 13 over 4. Nice fraction there. Cool. One last thing as well. So we spoke about how it was reflected in the x-axis, where you put a negative of that. A negative square root of x. Please note though that negative square root of x is different than this one here, the graph of y equals the square root of negative x. So where the negative x is underneath the square root sign, it's going to reflect the graph in the y-axis here. Yep. So instead of going this way, it's going to go like that. Now, obviously, you can also get the negative square root graph of negative x, which would obviously reflect it in both axes. Yep. So that one might pop up a little bit later on as well. Alright, I'll delete all this stuff so it's not so messy. Cool. Again, we've got the standard form of this particular graph. It says sketch the graph of y equals the square root of 2 take away x plus 3. What you need to note is 2 take away x is the same as taking out negative 1 as a common factor out the front. X take away 2, yep. And so by just doing that little trick there, it's now in this format, and you can go ahead and proceed. Yep. So when it's in this format, you can see this part here is going to be looking at where it's translated to. That part there, x would have to be positive 2 to make that bracket bit be equal to 0. Yep. So positive 2 means it's translated to the right by 2. Yep. Also, this plus 3 on the end means it goes up, translated up by 3. So again, if it's at 0, 0, it's translated to the right by 2 and up by 3. Your starting point is going to be at 2, 3. That's a 3 there, sorry. Cool. You also need to know that it's obviously the negative or square root negative x version of the graph. So normally they go like that, but this one is reflected in the y-axis. Yep, so it's going to go this way. Yep, so you know the direction it's going to go. Thinking logically as well, you can see that this one is not going to go through the x-axis, so there's no point trying to find the x-intercept, but you can see it goes through the y-axis. Yep, so you need to make x equal to 0, plug x equals 0 into here, square root of 2 take away 0 is the square root of 2 plus 3 as the solution there. Yep. There are some summary notes which you should take and put into your fun note booklet that will help you with this thing. The questions are listed on Compass for you to have a go at. Please have fun with another gallery of graphs. Bye for now.